Welcome back. So, so, for those of you who don't know who I am, I'm just a guy learning something new in my life. Actually, relearning something that I forgot long time ago. I used to program in C for 2 years in my college, and then when I started working in the industry, we mostly used web technologies, and one of the main web technologies is JavaScript. So more or less in the last 6 to 8 years, I haven't done any OOP. I mostly done programming with JavaScript or uh, JavaScript on steroids, which is TypeScript now. So I thought it would be a good idea to relearn some of the long lost knowledge of C, which is I I read a lot of articles and I read a lot of testimonials saying once you learn C, you are ready to learn any programming language. You are ready to incorporate C into any concept you wish to model or to create. And after spending now, I don't know, maybe 2 weeks trying to grasp it again, I see why and how that might be true. It's a it, it's like a sandbox. It's open for you to do what you want, and it doesn't hold hands for you. It's a it's like the Dark Souls of programming. It's there. It's fun. A lot of it's customizable. It's extremely customizable. But it's not holding hand. It has a steep learning curve. So that's it. Basically, what I'm doing, I'm trying to build a Lisp in C. I'm following a great book by Daniel Holden. I'm also trying to do a lot of stuff on my own, but I'm following a book by Daniel Holden called Build Your Own Lisp. So in the last episode, I had a bug which I only fixed after 1.5 hours of debugging. A pretty nasty boy. Yeah, that was a pretty nasty boy. So what I wanted to do now is the following. Let me just do this, and can I skip it left? Oh, it's like this. It's like Windows. Actually, it's not Shift. It's Action. What's the name of this keyboard? Doesn't matter. So let me just put this. There are three things I would like to do during this live stream. First one, I would like to review what. Yeah, I wrote the V and the W in two different ways, even though W is just a double V. But yeah, review. Uh, review the project until now. Okay, what's the second point? So the second point, do the bonus marks, and the third point will be just start. Let's do so. Start the next chapter. Okay, these are the three things that I hope I'll do. So without doing anything, let's do it. So first of all, if you come here to, I should have said this at the beginning. If you come here to learn anything, you came to the wrong place because I'm as knowledgeable as you, unless you are an expert in C. If you are a web developer, or if you, I, or if you are more or less basically knowledgeable about programming, I think that this would be great because you can learn together with me, and maybe you can see what how another beginner thinks of. If you are advanced, I mean, you can also watch this, but maybe you can watch it for the comedic values, I think. I don't know how many people watched the last episode where I spent 1.5 hours debugging this, and they must probably tear their hair from their head because they noticed that because they noticed most probably the issue immediately, but I didn't. Yeah, up until this end. Okay, so review the project. I'm doing this for the third time now. Now, C has this quality in which you both understand what is happening, but at the same time you don't. Compared to, I don't know, JavaScript, TypeScript, in which even if you even if you start a project for the first time, you kind of know just from experience what happens, behind the scenes. Here, it's so different. So while I can see some patterns, for example, there's a lot of memory management going on. There's a lot of clearing of data going on. There's a lot of moving of data going on, which is I assume which is one of the trademarks of C. Okay, I don't want to bother you anymore. Let's start this. And this will be a slow episode because I want to grasp this as much as possible. Okay. Main. This is the main. I'm gonna ignore all of this. I mean I'm just gonna glance over it. We are just creating parsers and we are creating a new language here called Lisp. Okay, I already know this. The latest additions to the code were the Q expression functionalities, in which we are just creating a completely new type that is not immediately runnable. That has no intrinsic logic behind it. It's just data, and then depending on some of the actions, we can do something with it. Okay, first things first. I'm gonna do this really simply. I'm gonna divide this ls. This will work, I think. Q expressions, and I can do maybe eval. It's like this. No, it's. I think it's like this. Head 1, 2, 3, 4. It's 1. Do I even need an eval for this? I think I will need an eval. Okay, so what do I have? I have an eval. I have head, and I have 1, 2, 3, 4. Maybe this isn't the best. So I want to create I want to create something. Okay, I think I know what I'm gonna do. So it's gonna be eval, gonna be head, and then I'm gonna have 1, 2, 3, 4, and I'm gonna debug it. All of this. Okay, let me just take another look. So this will be our example that we are gonna follow. Just a second. Just write it. It's gonna be eval or evaluate head. I'm creating a list out of 1, 2, 3, 4, closing the parentheses and closing the braces. I'm just gonna copy this because I'll almost probably use it a lot. Almost probably use it a lot, but where could I copy it? Yeah, let's move it here. Okay. So what I assume will happen here? We want to create a new Lisp value from whatever is read and evaluated from. So this is the main entrance of where, you know, everything is rooted and everything goes into the logic we've written. Okay, so let me just show you what's happening here. Okay, I'm gonna use GDB expressions. Where should I break it? I should break it at read, right? Where's the method called read? It's here. And also here's add. So I have add and I have read. What line is this? Break 313. Oh, no. Before I break it, yeah, let me do this. I have issues debugging it, so I'll just move this to new line instead of having everything at the same line. Just to make it easier to debug. Because what was happening before, I would debug it and I would try to step into the S expression methods or any other methods that are inside the if block, but it steps into the built-in substring methods and it isn't very nice. Yeah, I'm bloating the file size a bit. I'm sorry. I'm not doing this on purpose. Actually, I am. I want to debug. We can always prettify it up later on. Okay. Works? No. No. Where are you? Where are you, brother? Where are you? You are here. Yeah, but not here. Not here. Not here. Here. Yeah. Okay. Oh, this looks really ugly. This looks incredibly ugly. Okay, I need I will add this. Okay. So what line is this? So let's do this again. Q expressions. And what's happening? I'm gonna break it at 313, right? Yeah, it's 313. And I'm gonna break it at add again. 313, where's add? I'm gonna break it at 99. Break 313, break 99, run. This is my guy. Okay, first things first. First things first. Let me just use this to help me know where it's the read method. Oh, it's quite a big one. Can I just copy? So where am I? I'm here, 312, 312 all the way to 360. There must be a better way to copy up until, let me just ask. My good friend is, hey, if I am on line 313 inside Vim and I want to copy anything up to line 360, how could I do this? So here, where am I here? So what am I doing here? Yeah, 313, 360. Ah! I missed it. 31. Oops. Okay. 313, 360. Yank. Could you please walk me and explain this code if my input is the following? Okay, this is my input, but I'm not yanking them. How to copy it outside of Vim's clipboard? It's a plus. It makes sense. Can I? Oh, nice. I can do a plus. What? 313, 360. What? Why can't I do this? This should work. 3160. Invalid register name. But this works. But this doesn't. You lied to me, ChatGPT. You lied to me. Oh shit. Make sure Vim is compiled with clipboard support. Make sure Vim is compiled with clipboard support. No, it isn't compiled with clipboard support. Can I do this by hand? I don't have time to mess with. Yeah, I think it's a short one. It's short enough so I can copy it. Okay. Okay. This is the code that reads the input. Can you please explain and walk me through what is happening if my input is as follows? And I'm gonna debug it as well. So alvalad. Let me also copy alvalad. Where are you? You are here. I think I have a history of asking ChatGPT about this project. So I think he should know, or it should know, about little intricacies such as how the code that creates stuff and all the other things. The code you provide is possible for reading an abstract syntax tree. Yeah, it is generated from an input and converting into the internal data structure LL. Oh, okay, I forgot to add what's happening here. I'm creating a Lisp-like programming language. I'm inputting some kind of input, and I want to see what's going on. So first of all, we have an abstract search tree that is being created here, and then we want to model this abstract search tree into a Lisp value, which is a variable. So this is our input. Will be parsed by an external library. Yeah, it is parsed by an external library to an AST. The structure of this AST will contain various nodes representing the elements of the input. Each node will have a tag and potentially content. Yeah, this is it. So what's going on? We will most probably have. So how would this look like? Just a quick side question. How would the above mentioned input look as a visual representation of a AST. Yeah. So what's this? Let me just write this. So this is a Q expression. It's made of a symbol. I'm just gonna write this so I don't forget it. Then we have another consisting again of a symbol, head, and then an S expression, because S expression is inside braces. Then I have another list, and then I have one. Sorry. Simple. It's gonna be list. And then I have number one, number two, number three, number four. Okay. Okay. So I also I just I, I drew the same thing, not as good as ChatGPT, but decently. Yeah, so this is how it looks. Okay. So what do we have here? So we will have an input, checking for a number or a symbol. If a node in an AST has the tag handling S expressions, this section handles the root and container nodes. The input eval will be parsed as a Q expression because of the curly braces. So the tag of the root node will likely indicate that it's a Q expression, and the eval Q expression will create it. Okay. And then we are recursively reading child nodes. So how does this work? Okay. So the parser reads the root of the input. The root is recognized as a Q expression, and you I don't think this will work. We have a root which is the regular root of an abstract search tree, and then inside it we have a Q expression. Something stuck in my laptop. Okay, I got it out. So this is gonna be a symbol. This is gonna be a Q expression. Then again, recursively, it will do its magic, and then it will hit add. This new structure can be evaluated by the interpreter. Okay, so I'm gonna try to predict what's happening here in a moment. Just a second. Let me get my water. Okay, so Where are we? We are at line 313. If I print the tag, this is gonna be the root node. The root node. And it will have count. No, it's count is the Lisp value. Print children num. It's like this. It has 4 children. So the 4 children. What are the 4 children? 1, 2. How it has 4 children? Print children 0 tag. No, I didn't this right. Print t children 0. It's a regex. What's a 1? It's this. So let me just see. 0 is the content. I think it's content. No, it's not content. Content's it's an empty string. Why is it empty, brother? Why are you empty? Huh? What's 1? It's eval. What's 2? It's empty. And what's 3? It's also empty. It is. Ah. This. So I have a root node. I have eval. I have empties, but where do the empties come from? And what are they doing? Okay. Let me just ask ChatGPT something. Hey. When I tried to print out the contents of the abstract search tree with the input of before, I got the root node, which has 4 children. Just see something. Print t children 3 count with count. No, it's not count. It's children num. It has 0. Same way for 2, I assume. What's 2? And 1. 2 and 0. Okay, let me try to model this. Let me try to write this, how it would look like. Where is the tag? T tag. Okay, that's the main guy. Next, print t contents. It's empty. Print t children 3 tag. It's a regex. Why is it a regex? Children num. So the third one has no children. The last element. The second one has 4 elements. The second one is of type what? It's an expression. Children 0 tag. It's a character. Contents, it's an open brace. What's gonna be 1? It's a head. Ah. So there's a difference between how is this being parsed? It's not parsed as a real tree. It's not parsed as those Russian mating dolls. It's parsed as it's written. It just breaks it based on. So if I go to the code here, what I assume will happen is the following. So first thing is, okay, the root node. The root node. Where is eval? It's here. The children content and all. What? Okay, this is the type, the contable. But what's the type? No, not type. Tag. It's gonna be a Q expression, right? Expression, symbol, or string? No, sorry, it's gonna be a symbol. It's gonna be a symbol. But why is it expression or a symbol or a string? Why is an expression or a symbol or a string here? Expression or symbol or a string? If it's only a string, print. I have no idea what's happening. Contents. Okay. Let me ask you, why is eval? So I need to copy all of this. Why is eval tag considered expression or a symbol or a string? Okay. This is my language. Okay. So what's happening? The tag expression means that the node for eval is being categorized as a combination of the. I know this, but why? This happens because your parser generates multiple tags. Here's why it could be happening in your grammar. Eval is defined as a symbol, but since expression can also be a symbol, the parser may assign multiple tags for eval to capture all the possible contexts it might appear in expression, because yeah, it is an expression, a symbol, because eval is defined specifically as a symbol, yeah, and string because it's a string. The grammar rule for expression requires both symbol numbers, and when the parser encounters eval, it is processing it at both a specific symbol and as an expression. Okay. Makes sense. So that's why. So how is this broken into? Okay, I'll have eval, right? So eval is an expression or a symbol or a string, which makes sense. What is the first guy here? Print the children. No, the first guy. Children none. It's 0. What's your tag, brother? It's a regex. Why are you a regex? Contents. It's an empty string. What else? Is it just an empty space? It could be the space between Uh-huh. Could it just be the space between eval and the next thing here? I mean, it's highly possible. It's highly possible. It's highly, highly possible. Okay, let me also try this. Why do I get this for the first child? What is the first child? Zero children. It has no furtherness. It's a regex. Regular expression match. It's probably a node that was introduced by parse, but that's representative of a language. White space. Yeah, of course. I thought it was white space. This white space. An empty space. Yeah. Given that the first child has a regex tag and no content, it's likely that this node corresponds to some kind of structural token, like an empty space or ignored character. It's definitely an empty space. It's definitely an empty space. But why is the first child here? Why not the second? Now the second child as well is an empty space. It's empty. The tag is a regex. No. Children. None. And third one, 0. Tag. Regex. Now that, okay. How did he break this apart? Because now this is not very right here. This is not very right. It didn't break properly. Now, no, actually it is right, because this is the representation of an Lisp value. But the representation of an abstract search tree is different, because a representation of an AST is most probably the root. I just need to know why, why is this there? But yeah, I think it's empty space. It's either empty space or maybe it's this. Maybe it's the special characters. Maybe it is the special characters. Wait. So if the first child is empty, the second child is what? Eval. Third child is empty, but it is of type 0 tag. It's a regex. 1. It's an expression or a symbol or a string. It's an expression, a Q expression, or this. It's a regex. And the fourth one, it doesn't exist. Okay. So what's the first one? It's regex. And it's empty. The second one is expression or a symbol or a string, and what's the second one? Content, it's eval. Now the third one, it's empty, but it's a Q expression, right? Because yeah, it's a Q expression. Expression or Q expression or whatever this is. And the fourth one is just empty. Okay. Okay. So where are we? Line. What line are we at? We're 313. Next. So what's this? It's a root node. It's a root node, and the root node is a Q expression. No, it's not. Print t tag. Man, must be fucking kidding me. String compare, it should be the same one. Okay, it doesn't work in the debugging environment, it seems. It doesn't work there. Why didn't it? Why did it go here? It's this. It should work here, but for some reason it went the other way. Next, print the tag. Can't it? Have I messed something up? Huh? I think I did. I think I did. I'll show differences. Get diff. Okay, I just want to see, have I messed something up? Get status. Get diff. Get diff master. Why can't I see anything? Like this? No, of course not. I didn't save it. Ah, that's why it skipped. I didn't save it. Okay, I need to do this again. Okay, let me just see. Get diff. Okay, so these two guys are now on number symbol on new lines. What else? New lines. What's here happening? Simple. Ah, no. No, 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 no. Let me do this again. The only changes should be here. And they are. Okay. Which means we need to debug this again. Again and again. Break 313. Break. Add, where the hell is that? It's 99. Run. No, I don't need the debugger. What have I done? What have I done? What have I done? What have I done? This? Rerun. No, let's start R. Yeah, start from the beginning. Okay. Okay, okay, okay. Print t tag. Next. Next. What's happening? Why is this not working as it should? 316, where are you? 316. Next. Ah, okay, it goes line by line. Goes line by line. Print the tag. It's an empty. Next. Why does it? Sorry. What are the most commonly used GDB commands? Run, break, I know this. Step. Ah, what? What is the what is the tag? Ah, okay, okay, this is cool. I can also examine memory. There's a lot of commands here. A lot of those guys. So what should happen next? 319. It should hit here. Break three break. Can I unbreak shit? Break T3 true. 326, and now if I do continue, it hit here. No, it didn't. Oh, I need to do this again. Next. Here. Why did it hit? It's going line by line. Hello, like Q expression. Why did it hit? Why is it going like this? What's happening here? Do I know how to debug at all? The next line of code that enters a function if there's one. Run. Ah, step. Okay, this doesn't work. Continue. Okay, this doesn't work. I need to think about this. I need to think about how to debug this properly. Why does it trigger this line? That's the thing. I mean, I know in JavaScript, it just skips over code that is not triggered, but here it enters when I'm debugging it. It enters every line of code specifically. Info breakpoint, delete breakpoints, clear. Okay, let's do this again. I'm sorry, I'm an idiot, I know. It shouldn't be like this. It shouldn't be like this. It shouldn't be like this. But okay, let's try it. Break 313, run. And copy this guy again. Number. Okay. Next. Why does it hit here? Next, next, next. Next, next. So here, if string compare print t tag, if string compare t tag is equal to this, it is equal to this. Stepping into it. It's not. Why? Okay. Hmm. By default, GDB steps into each line of code when you use step. Even if it's a conditional statement, it will enter the line to evaluate whether the condition is false or true. But it's not this one. Next. If your code is compiled with optimizations using O2 or higher, the compiler might rearrange or optimize the code in ways that make debugging more difficult. This can lead to GDB stepping through lines that seem unrelated or unnecessary. Yeah, I mean, I did all of these. I don't know why. Is this a bug? I don't think it's a bug. I think I'm just doing something wrong. Breakpoints. Where? Break info. Info breakpoints. I mean, it's gonna do the same thing. I don't know why I'm doing this. Why doesn't it? Why? Why? String t tag number. Why is string substring undefined in GDB? Okay, maybe instead of CC, I'm gonna do GCC. I'm gonna remove this. What is the wall doing? Okay, so I have this compiling command. What are the flags doing? What is the wall doing? Okay, this is debugging information general executable. Okay, wall common warnings. Okay, this is okay. Let it. Ah, okay, this links it with a library, mat library, output file. Will this work? It works. GDB, Q expressions, break 313, run. I don't want to use any unnecessary. Next. It skipped it. I'm a fucking idiot. I'm such a fucking idiot. While for some reason I was compiling it the whole time with difference between GCC and CC. So I was compiling with it with CC. I think CC it's this is the GNU compiler collection, and this is a C compiler, which is the original Unix C compiler. on most systems, CC is either a symbolic link to GCC or to class. I think it's just okay. So I think the only difference was that I removed the flag that specifies the version of C to compile. I think that was the only difference here. I assume. 1 hour in. And we haven't even made it past the first method. But no worries. No worries, no worries. No worries. Next. Next. Okay, now it's gonna trigger. Yeah. Now if I step into this. Next. 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 It's gonna go back. Nice. It's inside the S expressions. Next. Just a second. Print T tag. This is the first guy. Next. Okay, now. Look at this. Look at this. What? Look at this. So now this is the root. It has 4 elements. And now we are gonna iterate through each of the 4 elements. Oops. Or through each of the children that it has. Let me see. Okay. Next. Okay, first of all, I0 print T children I contents. None of this will trigger. Next. No. Is it a regex? It is a regex. That's why it's. I think. Wait, tag. It's a regex, so it will continue, right? Next. And that will happen now. What will happen now? Are we gonna trigger the next element here? Next. Yeah. So print. So next. So what's the next guy? It's expression, a symbol, or a string. If I do next, we are here now. So which one will it trigger first? Which one will it trigger first? It will trigger read. So let me just see this. Oops. It will trigger the read first, and then it will. So we have something. We have a node in the abstract search tree that has the tag of expression, or a symbol, or a string. We have this type. So we will read all of the children of it, and then after we read all of the children of it, after we read all of the children of it, what will happen? We will add it to the existing Lisp value. So if I click next here, if I type in next, my guess is that we're gonna go back to line 313. Okay, and what do I have as a tag? I have an expression. What do I have as contents? It's eval, an expression or a symbol or a string. But this only happens if it's a clear expression, or this only happens if it's a clear number. No, it's not. It's not actually. Wait, print the children. Print the children num. It's 0. Oh, so it's an empty eval node. Okay. So this is an empty eval node. Ooh. Okay, next. It's a symbol. It is a symbol. Next, it's gonna create a symbol. Okay, I know what's gonna happen now. Now, if I click next, 359. I didn't even trigger add. Next, print the children num. It's 4, but the current I is 1. Print print the children I contents. It's eval. Why is it eval again? Why is it eval again? Tag. It says, yeah, it's an expression. Wait, if I go next, print I. It's 2. Okay. So I forgot to do this. Print I, print T, children I, contents. It's empty. What's a tag? It's a regex, right? No, it's not. Print T, children I. So this guy, children none. It has 4 children. So it's now it's going a level deeper. No, actually it's not. Okay. Okay, so it's going a couple of levels now. It's going a couple of levels now. But basically, the only thing it does, it's just, I think I know how this method works. It's the first method I've encountered here. But here's the gist of it. So we have some tokens. Let's say this is one, this is the second, this is the, I'm just guessing. Now inside the third, I have this, I have this, now I have this, I have each of these. These are all tokens that do something, you know, that should do something actually. So this method is just iterating through each of them and creating a representation of it based on abstract search trees. And I'll just do the same thing. Look at this now. I'm gonna break, is it 99? That's 99, where's 99? 99. It's here. Break 99. Run. So what is the type? It's 3. What's 3, 0, 1, 2, 3? It's an S expression. What else? Print the 0, 1, 2, 3. It's an S expression. Count. No, it's V. It's V. T is an abstract search tree. V is the Lisp value. It's 0. Print V 0, 1, 2, 3. It has no children because we haven't yet created any. So now if I go next, I'm reallocating this. Print V cell. V cell. Size of V count 1. What is this method doing? Can you explain me step by step using the same example input as before? Yeah, it's adding an ELWell. I know this. I'm just interested in how reallocate works. This represents the list or container to which you are adding elements. In your case, V would be the Q expression or an S expression. This is the new element. I'm increasing the count. Okay, resizing the memory. V cell is an array or list that holds pointers to LL objects. Reallocate resizes this array so that it can hold one more element. The new size is size of LL times V count, meaning that it's just the memory allocation based on how many elements. Next. Print V, okay. Wait, where am I? I'm here. Print V count, print V cell 0. So reallocate the values. Are they created at random memory locations? Okay. Example. So V cell previously had room for 2 elements, but now since count is incremented, you need room for 3 elements. This line adjusts the size of V cell to hold 3 elements. Boosting your input, parsing eval. This is a symbol. Then we hit add. LL read creates an LL for head, and LL add adds it to inner as a Q expression. The count of the inner Q expression is incremented, memory is resized, and head is placed at index 0 of the inner Q expression. Creates an LVL for head. Then this is parsed, the inner Q expression then processes the S expression. First, this is parsed as simple, and no, the LVL objects are not created at random memory locations. They are allocated in a managed region of memory known as the heap. The reallocate function shows that memory for memory. Each block of memory you request is allocated at some specific location within the heap. At some specific location. So it's still random. It's only inside the heap. The location is not random. It is determined by the operating system with the memory allocated based on what memory is currently available. But it's random based on what's currently available. Ah, it can vary with each run, yeah. Yeah. If there is enough space directly after the current memory block. New block of memory. Yeah, this is actually what I thought is happening. So, next, return v, continue, print v tag, print v type 4, 0, 1, 2, 3, 4. It's a Q expression. Print v, is it a symbol? It's not. Print v, it's not even a number, right? Print v count 0. V type. So this is just telling it that it's a Q expression, then it will create child elements inside of this Q expression. Next. And again, I'm reallocating print v. I don't know how to get the parent elements here, right? Print v, it's 0 because we are at the child element. Yeah, we are at the child element. The size of cell is the struct depends on the system architectures. Here's how to understand. It's a pointer to a structure. Where are you? It's a pointer to a structure. It means cell holds the address of an array of pointers where each pointer points to an LL structure. The size of any pointer in C is determined by the architecture of the system. Size of, is this working? Prime size of L1. Size of no, this doesn't work, so I need to do this. Struct L1 cell. Fuck this. Prime size of V cell. It's 8. It's 8. So what's happening here? The size of L1 cell would be 8 bytes. Okay. So because it's a pointer, it only points to a memory address. It's not a full congruated memory size. Okay, okay. I think I got some things here. We got something done. What I wanted to do next is to solve some bonus marks, but 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 I think I'm gonna create a quick break, but before I do this, let me just do print size of v. But what's v? V is why is size of it's 48. It's 4. It's 4 because the type, what's the type? It's a string. It contains of 4 bytes. Ah, okay, here it is. So int, it's 4 bytes on most systems. Holds an integer value. Okay, this is 4 bytes. This is 4 bytes. It's a pointer. This is also a pointer of 4 bytes. This is a pointer to an array of pointers. It's also 4 or 8 bytes. So it's, but why is it 24? Ah, it's 48. 48. Okay. I'm getting it. I'm getting there. I'm getting there. Yeah. Let's stop it. Let's stop it for a bit. I'm gonna end it here. A bit. Oh, it's already 1.5 hours of debugging. I need to stop. I need to relax a bit. I'm gonna come back. I'm gonna get something to eat, and I'm gonna start a new one. I think the new one will be about Python. I'm not yet sure, but let's see. Thank you all for watching, and I got two new subscribers, so thank you.